next unit is on mass spectrometry. And so a mass spectrometer is just as simple as all these other instruments that we've talked about this semester, in that it can be divided up into three relatively simple parts, and then we're going to talk about each of these parts in more detail. So the first thing you have to do is you have to take a neutral ion and ionize it. Sometimes that involves breaking it into pieces, but first you have to ionize it and then you have to accelerate it. So you need some ionization method. Then you need separation or selection, some way to separate the ions that you've made. They're often a mixture, and so we need some way to separate the ions or select for a specific ion that we're looking for. And then we need to detect it, so we need to detect the ions. And so this whole technique is based on a mass to charge ratio, and so for the most part we deal with +1 charges because we take an electron away from a molecule in order to ionize it. And so usually we're looking at just a m over what +1, but you could potentially look at m over +2, and then you'd be looking for an m over 2. So whatever the mass of the molecule is, your molecular ion would be that mass divided by 2 according to the mass spec results. Okay, so let's look in a little bit more detail at the ionization methods. There's a whole slew of ionization methods that you can use. The first one is electron ionization, and we're going to talk about that one a little bit more in detail. Same thing with chemical ionization, where it's very similar, but you use a reagent gas. Also electrospray ionization, atmospheric pressure chemical ionization. You can have DART and MALDI, which stands for matrix assisted laser desorption and ionization, so MALDI. So the next step is then, after you ionize your sample, then you're going to be wanting to look at a specific ion, specific mass to charge. And so you need to either select for that or separate to do that. And so you can sort of think of it either way. And there's three different ways to do that we're going to talk about in this class. The first one is magnetic sector, where we're going to use a magnetic field to bend ions, and depending on their mass to charge ratio, they'll bend at different amounts. Lighter ones bend more, heavier ones bend less, and so you pick your mass to charge ratio that you're interested in, and you adjust the magnetic field so that only that one mass to charge is being detected. The next one is a quadrupole, and then the last one is a time of flight, or usually abbreviated by TOF. So once you've separated and are looking just at the one specific mass to charge ratio that you're interested in, we're going to need to detect it. And so we have ions that are going to come into the detector, and we need to generate either a current or a voltage, and we'll actually generate a current that we can then easily convert to a voltage.